bottom, sir.
Okay.
Yeah, I'm able to see your screen, sir.
You told me that annotate something like that.
Sir, once you start sharing the screen, you will get it in security.
No, no.
Right now, annotation is disabled, sir.
Okay. Mm.
So you require the annotation.
No, no, no. You told me that that is to be disabled, right?
I have disabled it, sir. It is
Yes.
not there right now.
So I can continue now.
Yes, sir, you can continue.
Right, sir. Thank you. Where is the record option? Yes, good afternoon, students. Yesterday we have seen projections of straight lines. Now we'll deal with projections of planes. That is the next topic in second unit. So now, before going to the problem, we'll see the brief description. The types of planes. In fact, planes can be classified based on their shape. We know there are different types of shapes in planes. That means, in one word, we can say plane is a flat surface with certain shape. So, if you take the shape of the plane as a criteria, you can classify planes. Similarly, by taking the position of the plane as the criteria, we can classify the planes broadly into two types. Okay. Uh, so now here we are taking the position of the plane as a criteria. So by taking the position of the criteria, planes can be broadly divided into two categories, such as perpendicular planes and oblique planes. Now, perpendicular planes are further divided into three more types. A plane with its surface perpendicular to both HP, VP, a plane with its surface perpendicular to one and parallel to the other, a plane with its surface perpendicular to one and inclined to the other. So, these are the two types of planes. Now, let us go with first one, a plane with its surface perpendicular to both HP and VP. So now the question is like this. In fact, the statement was not given here. A square ABCD of say 40 mm side is perpendicular to both HP and VP. So when the plane is perpendicular to both HP and VP, plane shape is not going to be seen on HP and VP. For that is the reason we have taken the help of profile plane here. So as HP, VP, PP, all the three planes are mutually perpendicular to each other. When anything or when a square or rectangle, any plane is perpendicular to both HP and VP in the sense, obviously it is going to be parallel to PP, profile plane. So remember one thing, whenever any object is parallel to a reference plane, then only we can see the true shape of the given object on that particular plane. So now here, according to the given position that the square is perpendicular to both HP and VP, it became parallel to PP. So as it became parallel to PP, we can get the true shape of the given square on profile plane. So here you have to take two reference lines such as XY, X1, Y1. So XY is reference line, X1, Y1 is line. So here in this, this is what it is representing, vertical plane, and this is horizontal plane, and this is profile plane. Now, as we said that the shape of the plane can be seen with its true shape on profile plane. First of all, you have to draw the true shape on profile plane. And afterwards, by taking the proportional projectors, you can draw front view on VP, top view on HP. So this is how the first position is. Coming to the next one is perpendicular to one. The second one is a plane with a surface perpendicular to one and parallel to the other. So here the rectangular plane with sides 40 and 25 mm, which is perpendicular to HP and parallel to VP. Remember one thing, a rectangular plane is parallel to HP, perpendicular to HP and parallel to VP. So as far as the rectangular plane is perpendicular to HP, we are going to get a line on HP. And as it is parallel to VP, we will get true shape, that is rectangular shape in VP. So as soon as you realize this point, I mean, when the plane is parallel to VP, no doubt, we can get the true shape on VP. We can draw the true shape on VP like this by taking the proportional dimensions, what it was given in the problem. And subsequently, 20 mm interval should be taken to draw the top view, because if you observe the problem, a rectangular plane of sides 40 and 20 mm is perpendicular to HP and parallel to VP. So in the first statement, we can realize or we can understand that the plane is perpendicular to HP. So we will get the line on HP and it is parallel to VP. So we will get the rectangular plane itself on VP. Now the question is how to draw or where to draw. Finally, images we have understood how to get the shapes or what kind of shapes that will come on HP and VP respectively. Line will come on HP because it is perpendicular to HP. Rectangular plane will come on VP because it is parallel to VP. Now, the nearest side is being 10 mm above the HP and 20 mm in front of VP. So, by taking this as a reference, so 10 mm above the HP, this is what the nearest edge of the rectangle, which is supposed to be 10 mm above. So, by taking the longest side 10 mm above, and you can finish up the regular shape of rectangle ABCD with 40 by 25 mm, and the same edge is 20 mm in front of VP. So below the XY line, you should draw the line 20 mm below because it is 20 mm in front of VP. So that is the second category problem, a rectangular plane which is perpendicular to one and parallel to the other. With more clarity, it is perpendicular to HP and parallel to VP. So in that particular problem, the rectangular plane is in its right position. In its right position. For example, if this longer side of the rectangular plane of sides 40 by 20 mm is inclined at 40 degrees with HP. Earlier, the longer edge or the nearest edge is parallel to both HP and VP. Both HP and VP, which is 10 mm above and 20 mm in front of. But now, the same edge is making an angle of 40 degrees with HP. Then the plane is perpendicular to HP and parallel to VP. So the surface of the rectangular plane's position remains the same. The surface position remains same, such as parallel to VP and perpendicular to HP, or perpendicular to HP and parallel to VP. But in the earlier problem, two edges of the rectangle or the longer edges of the rectangle are parallel to HP and the short edges of the rectangle are perpendicular to HP. But now, here there is a small change, such as a small change in the sense in the position of the edges. The longer edge is making an angle 40 degrees. So you have to take like this. Earlier it was drawn horizontally parallel to XY, but now as it was clearly mentioned that it is making 40 degrees with HP, you have to draw B dash C dash with 40 mm length at an angle of 40 degrees. So with this base edge as a reference, you can finish the rectangular shape A dash, B dash, C dash, D dash with 40 mm and 20 mm size. Now you can draw the top view like this. Again, there is a gap of 25 mm from VP to the rectangular plane's surface. So we have taken 25 mm below to draw the top view. Here one point is to be observed: when you are watching from the top, A, D, C are visible, B is not being visible. So A, D, C are visible, but B is not. Because when you are watching from the top, only these 3 points are visible. As B is coming at the bottom, that means before B, there is certain surface which is objecting you to watch point B. So it becomes invisible. So we have to kept point B in brackets. So that is the second model. Now coming to the next problem, the 50 mm diameter of the circle is parallel to HP and perpendicular to VP. If the center is 40 mm in front of VP and 15 mm above the HP, draw the projections. Draw the projection. So the diameter of the circle is parallel to HP. So when you are assuming, when you are reading it out, that the diameter of the circle is parallel to HP, you can assume that the entire surface of the circle is parallel to HP and perpendicular to VP. So in the earlier two problems, the surface of the rectangular plane was perpendicular to HP and parallel to VP. Perpendicular to HP and parallel to VP. But now the surface of the circular plane is parallel to HP and perpendicular to VP. So here the reference is center for us. So center, once again I'll tell you, the diameter of the circle is parallel to HP. That means the entire surface of the circular plane is parallel to HP and perpendicular to VP. So the surface of the circular plane can be seen as a circle on horizontal plane because it is parallel, and it is going to be appear like a line on VP because it is perpendicular to VP. Remember, there are three relations in engineering graphics, particularly in projections: parallel, perpendicular, inclined. If you apply these three relations to any object, parallel will give true shape in itself, whether it may be line, plane, solid, whatever. If you go with the relation perpendicular, one dimension is going to be neglected. For example, if you take or if you apply perpendicular to a line, the line has got only one dimension which is going to be neglected. So you will get a point. Similarly, if you apply perpendicular relation to a plane, as planes are two-dimensional, one dimension is going to be dissolved. So only one dimension will be seen. For that is the reason for all the planes, in case of they are perpendicular, we are able to get them as lines. So when in case of parallel, we'll get the true shape. In case of perpendicular, we'll get the line. In case of planes, when the surface is inclined, there will be partial reduction in the shape. So parallel will give you true shape, perpendicular will give you maximum reduction, that is one dimension will be neglected, inclined will give you a partial reduction in the shape of the given object. So now by reading the first sentence of this problem, a 50 mm diameter of a circle is parallel to HP and perpendicular to VP. Here we can guess the final shapes that are going to come on HP and VP. So parallel to HP in the sense, true shape will come on HP. Perpendicular to VP in the sense, a straight line will come on VP. So always we have to start with the view where we can get the true shape. So firstly we have to draw XY line, and we have to draw the circle on horizontal plane, that is for sure. But while drawing the circle, you have to take the center of the circle as reference. So in the problem it was mentioned like if the center is 40 mm in front of VP. So from XY line you have to take a point at a distance of 40 mm from XY, and with that point as the center, you have to draw 40 mm diameter circle. 40 mm diameter circle and name it as AB. AB, here AB is the diameter of the circle. So now the top view is finished with the true shape. Now from here you can draw the front view by taking an interval of 15 mm, because in the statement it was given the center of the circle is 40 mm in front of VP and 15 mm above the HP. So here we should mention C as a center. I forgot it. C will be the center. So C will come over here as a center in top view. C dash will come here exactly at the center of A dash B dash as C dash as its front view. So this is how the problems will come in first two categories of perpendicular planes. Now coming to the third category in perpendicular planes. In perpendicular planes, first one is a plane, its surface perpendicular to both HP, VP. And the second one is a plane with its surface perpendicular to one and parallel to the other. So these two models we have covered so far. Now the third one in perpendicular planes is a plane with its surface uh, right. A plane with its surface perpendicular to one and inclined to the other. Inclined to the other. Now let us read out the problem. The given problem here is a pentagonal of a pentagon of side 25 mm is inclined at 40 degrees with HP. So you just remember, students, the pentagon of side so and so is inclined in the sense, though it is not mentioned in the statement, you should realize or you should understand pentagon of 25 mm side in the sense the surface of the pentagon of side 25 mm. See, if you see the earlier topic, that is projections of straight lines, if you take any problem, the problem will be usually started with a line so and so, a line so and so, a line so and so. But there we are more concerned with the straightness of the line. Whether it is mentioned in the problem or not, we are dealing with straightness of the line. So that straight line we are taking. But usually it is so called as a line, a line AB, a line PQ, a line MN, a line CD, something like that. So there in case of straight lines, we are concerned with the straight or straightness. So as simple as that, whether it is mentioned or not, in plane's case, we should concern with the surface. Usually it will not be mentioned in the problem. Here straight away it was given as a pentagon of side 25 mm is inclined at 40 degrees with HP and so like that, So here we should analyze or we should understand that the surface of the pentagon of sides 25 mm so like that. So now the pentagon of 25 mm side is inclined at 40 degrees with HP in the sense, what here we should understand is the surface of the pentagon of 25 mm sides is inclined at 40 degrees. So the other position is the side is perpendicular to VP and 15 mm above the HP. Draw the projections of the plane, right? So now you remember one thing. Just now I told you, when the surface is parallel to any plane, let us suppose, for example, for our understanding, let us take a horizontal plane now. A pentagon is parallel to HP in the sense, we will get the true shape of the pentagon on horizontal plane for sure, no doubt. If the pentagon is perpendicular to HP, no doubt a straight line will come on horizontal plane. Similarly, here in this particular problem, the pentagon is inclined at 40 degrees. Doesn't matter with the numerical value of the angle, it is inclined. So as it is inclined, no doubt, definitely there is going to be a reduced shape of the pentagon on HP. And we don't know the exact reduction of the shape of the pentagon. So what do we know? We know the actual size or true size of the pentagon or true size of the regular pentagon with 25 mm sides. So in order to get the true shape of the, because we don't know about the amount of reduction, we know the true shape. So to get the reduced shape, we have to start with the true shape. As we cannot directly get the reduced shape on horizontal plane, let us start with the true shape, because the true shape is a known shape with 25 mm sides, regular pentagon. So to get the regular true shape on horizontal plane, we have to make it parallel to horizontal plane. We have to make it parallel to horizontal plane. So as it is mentioning that it is inclined at 40 degrees to HP, which will give us an unknown shape, or else we can say an unknown size. For example, if it is regular pentagon with 25 mm, we can say that it is regular shape. But whenever it is being reduced in its shape, we cannot say that it is particularly regular. So that reduced shape we don't know. So the known shape is a pentagon with 25 mm side. So, in order to get the reduced shape, firstly we have to start with the true shape. To start with the true shape, the relation must be parallel. So, you have to assume that the pentagonal plane is parallel to horizontal plane. You have to assume like this, and you have to draw the set of two views, front and top view. The side is perpendicular to and 15 mm above the horizontal plane. So the side AB, this is to be fixed. This is to be fixed. So the shape position of the surface is given. That is okay. In addition with that, one edge position is also being fixed according to the statement of the problem. The side is perpendicular to VP and 15 mm above the horizontal plane. So one side or one edge, that is AB, is perpendicular to the horizontal plane, perpendicular to vertical plane, and 15 mm above the horizontal plane. So A dash B dash is 15 mm above the horizontal plane. Now let us assume that the entire surface is parallel to horizontal plane. It is an assumption. Take this as an assumption. Draw the true shape of the given pentagon with 25 mm sides. So A, B, C, D. Proportionally, you will get the straight line in front view as its front view of the given plane, which is 15 mm above. So after that, now this is going to be inclined at 40 degrees, because here we have taken parallel to horizontal plane. This is purely for our convenience or for the simplicity of the solution. But at the end of the solution, we have to reveal that assumption what we have taken earlier. So timely we have taken the assumption such as the surface is parallel to HP. As one edge is being already 15 mm above, the entire surface is also 15 mm above. Then only we can say it is parallel, So 15 mm above horizontal plane, the entire surface is said to be parallel to HP now. So in the next stage, what I am going to do is, this straight line is going to be rotated or tilted to an angle of 40 degrees, what it was given in the problem. So in the next stage, you have seen it. Here if you see, BD is same as that of BD over here. This B dash D dash in initial view is same as that of B dash D dash dimensionally. Dimensionally, these two are same, but positionally they are different. Here the position of B dash D dash is parallel to XY. That is according to our assumption. But now B dash D dash here is 40 degrees inclined to HP. That is given position in the problem. Given position. So by taking the distances of B dash C dash, you can mark here. All the remaining points are marked according to the earlier position. We are not changing any position of any point on the line. A and B are at the beginning. So A dash, B dash are at the beginning. C, E are coming somewhere here. So you just measure the distance between B dash, C dash. Proportionally, you mark here. And after that, D, however, it is at the end. So the next step is, you have to drop the perpendicular projectors from all the existing points in the secondary front view. So there are 5 points in the secondary front view. A and B are at one position. So draw one vertical line. So this vertical projector is representing 2 points, A and B. So A vertical, A horizontal. This is going to be point A in its secondary top view. Similarly, the same line, even it is representing B as well. So B vertical, B horizontal. So this is B. The next one, we have taken one more projector from CE. So E vertical, E horizontal, E. C vertical, C horizontal. This is C. Finally, D vertical, D horizontal. So now, if you observe here in the secondary top view, the shape is reduced. The shape of the pentagon has come in secondary top view. This compression has come, or this reduction has come purely because of the angle what we have taken. So that is the reason I told you, parallel position will always gives us true shape. Perpendicular position will give us maximum reduction. That means one dimension will be completely neglected. In inclined position, there will be partial reduction. And that partial reduction will be depending upon the amount of angle. So this is the third position in first case. The third one is a plane perpendicular to one and inclined to the other. So coming to the next one, let us get back to the first slide once. Perpendicular planes. A plane with its surface perpendicular to both HPVP that we have seen by taking an example of square, which is perpendicular to both HPVP. Then we'll get the true shape on profile plane. And next the position is a plane with its surface perpendicular to one and parallel to the other. We have taken two examples, one rectangle and the other, another one is circle. So rectangle is parallel to VP and perpendicular to HP. And one more example we have seen in the second case, that is circle parallel to HP and perpendicular to VP. Now, in the last case in first category, that is a plane with its surface perpendicular to one and inclined to the other. Now, just now we have seen pentagonal plane problem. Coming to the second case, that is oblique planes. Here, the maximum number of problems will come in the final examination from this category, oblique plane. Oblique plane. A plane with its surface inclined to both HP and VP. HP and VP. Somebody is saying that, sir, can you explain the first type of the perpendicular planes once? I'll share this video to you later after completion of this class, so you can go through it and you can learn from it, or else I'll get back once. So the perpendicular, a plane with its surface perpendicular to both HP and VP. So here we have taken, in fact, I have not given the statement here, or else I'll explain now. A square ABCD of 40 mm sides is perpendicular to both HP, VP such that the bottom edge is 20 mm above the HP and its adjacent side is 10 mm in front of VP. This is how you can take the problem according to this solution. A square plane ABCD with 40 mm sides is perpendicular to both HP, VP such that the bottom edge of the plane is 30 above the HP and 15 mm in front of VP, something like that. Don't bother about the numerical values. So as far as this square is perpendicular to both HP and VP, as I told you, though it is two-dimensional square shape plane or square shaped plane, one dimension will be completely neglected because of its position perpendicular. As far as the square plane is perpendicular to both HP and VP, are going two lines with 40 mm on HP and 40 mm on VP, just because of the position that is perpendicular to both HP and VP. But we should always start with a view where we can get the true shape of the plane. That should be remembered. Always we have to start with a view where we can get the true shape of the plane. So, as I told you, VP, HP and PP are mutually perpendicular to each other. When the square is perpendicular to both HP and VP, obviously it will be parallel to PP. No doubt, obviously the square ABCD will be parallel to profile plane because it is perpendicular to both HP, VP. So, for that is the only reason we have started the side view on profile plane. In order to get the true shape of the plane, or in order to show the true shape of the plane on profile plane, we have taken two reference lines over here, XY, X1, Y1. So X1 xy is like this initial reference line, x1, y1 is this one secondary reference line. So, firstly, we have to draw the true shape of the square on profile plane. While drawing the true shape of the profile plane on true shape of the square on profile plane, the bottom edge should be 30 mm above. So 30 mm above, you have to draw one line with 40 mm, and its adjacent side is 15 mm in front of VP. So this interval should be 15 mm. So this interval is 30 mm and this interval should be 15 mm. So by maintaining these two intervals, 30 mm and 15 mm from horizontal plane and vertical plane respectively, you draw these two lines with 40 mm and 40 mm right angles to each other. And after that, you can complete the regular shape of square like this. So A dash, A1 dash, B1 dash, C1 dash, D1 dash. Afterwards, you project them to front view, you will get 40 mm line like this. Similarly, you project them from side view to top view like this, you will get one more 40 mm line over here. Now, the gap between the line and x1, y1 is of our choice. There is no condition, there is no particular condition for this interval. Slightly, you want to draw somewhere here, you can. Or if you want to draw somewhere nearer to x1, y1, you can. So there is no condition for this particular value, but this is to be 15 and this must be 30 according to the problem statement what we have taken. So that is all about perpendicular planes. Now coming to the second one, that is oblique planes. So oblique planes in the sense the surface inclined to both HP and VP, right? So now we have to make the surface of the given plane, whatever it may be, we have to make the surface of the given plane which should be inclined to both HP and VP. So let us take one problem and we'll see the solution, how it is going to be. Yes, it is. Projection of a pentagon of side 30 mm has a side parallel to horizontal plane and 50 mm above it. It is inclined at an angle of 40 degrees to HP. If the top view is inclined at an angle of 30 degrees to VP, draw the projections of the pentagon. Once again, I am reading this problem. A pentagon of side 30 mm has a side 30 mm, side parallel to HP and 15 mm above it. Sometimes the side may be resting on horizontal plane, but for a change, sir has taken, in fact, this presentation is being prepared by our senior faculty, Lakshman Rao sir. So, a pentagon of side 30 mm has a side parallel to horizontal plane and 15 mm above it. So here we can understand that the surface of the pentagon is parallel to horizontal plane. Now the surface is inclined at an angle of 40 degrees to the horizontal plane. 40 degrees to the horizontal plane. So the top view is inclined at an angle of 30 degrees to the VP. Draw the projections. So as I told you, the pentagon of side 30 mm. So the given plane is pentagon with 30 mm side. Okay. Next, it is inclined at an angle of 40 degrees to horizontal plane. Which is inclined at 40 degrees to horizontal plane? The pentagon is inclined at 40 degrees to the horizontal plane. What does it mean by pentagon is inclined at 40 degrees to HP? The surface of the pentagon is 40 degrees to HP. This is how you have to analyze. It will not be mentioned like the surface of the pentagon is inclined at so and so. But still, you have to realize that whenever a pentagon is inclined at 40 degrees, that doesn't mean the surface of the pentagon is inclined at 40 degrees to HP. Clear? Now the top view of this pentagon is inclined at 30 degrees to VP. Of course, this is second phase. Now, pentagon is inclined at 30 degrees. Top view is inclined at 30 degrees. So first and foremost, we have to take this as our reference to make it parallel. Because wherever the surface is inclined, there you have to take the assumption as parallel. Once again, I am telling you, without taking this assumption, you cannot start the problem at all. So wherever the surface is inclined, there you must assume that it is parallel. So now we'll go to the problem. Now you have firstly draw an XY line, something like this. You have to assume that the polygon should be parallel to HP. You have to assume like that because the pentagon is inclined at 40 degrees to HP. That is what it was given problem, given position in the problem. Sorry. The given position in the problem is 40 degrees inclined to HP. But you have to make it parallel to HP. So by assuming that it is parallel to HP, as soon as you assume that it is parallel to HP, no doubt you can comfortably draw the true shape of the pentagon on HP. So we have drawn it. Here this interval is of your choice. The interval between pentagon to the XY line is of our choice. There is no particular mention about this gap. Fine. So after drawing the true shape of the pentagon on top view, that means on horizontal plane, just project it to front view. Project it to front view by taking an interval of 15 mm because it is clearly mentioned. The edge is parallel to HP and 15 mm above. So this interval should be 15 mm. So this is initial front view, which is parallel to XY line. It is just because of our assumption. Once again, I am telling you. And in top view, we got a true shape of the regular pentagon. This is also happened just because of our assumption. Now, in the next stage, we are going to the given angle that is 40 degrees to horizontal plane. You know, the given angle is with horizontal plane. For that is the reason it can be seen in VP. So now, the same length is to be taken. The same length we have taken and rotated it to an angle of 40 degrees. The position of A dash, B dash is beginning. D is at ending. You just measure the distance of CE either from A or D, whichever it is convenient to you, you can. You mark point C and D somewhere here. Afterwards, you have to draw the perpendiculars from front view to top view or VP to horizontal plane and the horizontal projectors from top view to top view. So front view to top view, vertical projectors have been drawn. Horizontal projectors have been drawn from top view to top view. If you take the proportional lines like A vertical, A horizontal, you will get A. B vertical, B horizontal, you will get B. C vertical, C horizontal, C. D vertical, D horizontal, D. And E as well. So this is the reduced shape of the pentagon with an angle of 40 degrees with HP. Now in the next stage, he is saying that the entire top view is to be rotated to an angle 30 degrees. In fact, if you assume that it is perpendicular to VP, for example, this PQRS rectangle was drawn around the reduced shape of the pentagon ABCD. ABCD is the reduced shape of the pentagon. Around the reduced shape of the pentagon, we have created or we have drawn a rectangle ABCD where, sorry, PQRS rectangle we have created. So PQ is rectangle horizontal, sorry, XY line. PQ is perpendicular to XY. Even SR is also perpendicular to XY. Whereas PS and QR are parallel, that is secondary. Now we have to rotate PQ to an angle 30 degrees. In fact, if you extend it, it will meet somewhere here. This angle will be 30 degrees. So that is what it was given in the problem. So the entire top view should be rotated to an angle 30 degrees and we have to draw the projections. So if you rotate the rectangle PQRS to an angle 30 degrees, this is how it will come. And you can take the proportional distances of A, B, C, D from all available four corners PQ. For example, first rotate the rectangle to an angle 30 degrees. So PQ is 30 degrees, QR perpendicular to PQ, RS perpendicular to QR, SP perpendicular to RS. Now, A and B are on PQ. A and B are on PQ. So, measure the distance of A from P and mark here. Measure the distance of B from Q because it is convenient. So, mark B from Q. Suppose if you want to measure A from Q, B from P, that is your choice. Based on the convenience with the protractor or compass, what you are using, compass, not protractor, sorry. With the compass flexibility, you can measure these distances. And similarly, C is on QR. So C can be measured either from Q or R. You mark here. Like that, you can mark all the 5 points of pentagon ABCD and just look at them and join ABCD. You will get the reduced shape of the pentagon at the given angle. So here it is reduced, but it is not at the given angle. It is still perpendicular to VP. But now the given position is 30 degrees to VP. So we have rotated it to 30 degrees. So after rotating it, this becomes our final top view. Final top view. After getting final top view, you have to draw the projections again from all the 5 points. So vertical projector from A, horizontal projector from A. So this is going to be final front view point of corner A. Similarly, B vertical, B horizontal, C vertical, C horizontal, D vertical, D horizontal, E vertical, E horizontal. Better, my suggestion is always you draw the projectors from one particular corner, because if you draw all the vertical lines and later all horizontal lines, you will get confused for sure. So always try to draw the projectors from only one particular point or one particular corner. A vertical, A horizontal, B vertical, B horizontal, something like that. You will get 5 points again in final front view. So A dash, B dash, C dash, D dash, E dash. If you join them in the same order, A, B, B, C, C, D, D, E, E, A, you will get one more reduced shape in final front view. Final front view. So this is the final front view and this is final top view, which have come at the given position. The surface inclined at 40 degrees to HP and at 30 degrees to VP. So this is how you have to draw. Next, a circle problem is there. Circle problem is also same as that of the earlier. The circle of diameter 100 mm is resting on a point on its circumference on HP. And the circle is inclined at 45 degrees to HP and the top view is inclined at 30 degrees to VP. Draw the projections of the circle. So earlier the circle of diameter 100 mm is resting on a point on its circumference on HP. In the earlier problem, the edge of the pentagon is not resting on HP, it is 15 mm above. Are you getting it? The reference is an edge of the pentagon, that is okay, but the edge of the pentagon is not at all there on HP. There is a gap of 15 mm. But now the reference point is given for a circle plane here in this problem. The reference is a point on the circumference of the circle, a point on the circumference, but it is completely on horizontal plane, completely on horizontal plane. So this is how it is. As the circle is inclined at 45 degrees to the horizontal plane, you have to make it parallel to the horizontal plane, as I told you. Before going to achieve 45 degrees inclined to horizontal plane, you should make it parallel to horizontal plane. So as soon as you make it parallel to horizontal plane, you will get true shape of the circle on horizontal plane. So this is how we have drawn circle on horizontal plane. And the front view will come directly on XY line because one point on the circumference is already on horizontal plane. There is no gap here, students. If it is some gap, the same gap will be reflected in front view. But as it is directly mentioned that it is resting on horizontal plane, the front view will be coming on XY line itself. The same line here it was drawn in green color. It is looking so light. So will be rotated to an angle of 45 degrees according to the problem. So after dividing the circle into 12 equal divisions, the points were not marked because they are looking very clumsy. Either you can name them as A, B, C, D, F, so on, or 1, 2, 3, 4 up to 12. That is of your choice. So after marking the points in initial front view, just rotate them to an angle 45 degrees with the same length and with same proportional distances. You will get secondary front view. After getting secondary front view, drop the projectors vertically from front view to top view, horizontal projectors from top view to top view. Then you will get a reduced shape of the circle like this as secondary top view. Again, the reduced shape of the circle is surrounded with the rectangle A, PQRS again. The reduced shape of the circle is looking like an ellipse. Now it is surrounded with the rectangle PQRS. Now this PQRS should be rotated to an angle 30 degrees with VP. So 30 degrees with VP. Now, as it was not given which side is be inclined at 30 degrees. So here PQ is inclined at 60 degrees, but PS is inclined at 30 degrees. So in either way, you can take no problem. If you want to take PQ inclined at 30 degrees, you can, or else you can make PS inclined at 30. As it was not clearly mentioned in the problem, either way you can rotate it. After rotating, again you have to mark all the points. So 1, 2, 3, 4 up to so on. So 1, 2, 3, 4 up to 12. Points will be marked in final top view as well. And from final top view, again, you have to project them to final front view, vertically and horizontally. So the set of horizontal and vertical projector of a particular point will give you the corresponding points 1, 2, 3, 4 up to 12 again in final stage. So if you join all of them in the same order 1, 2, 3, 4 up to 12, you will get the reduced shape here in this final front view. So this is the final set of two views. This is final front view and final top view. This reduction has come just because of 45 degrees inclined to HP and 30 degrees inclined to VP. So this is how the projections of planes can be answered. So with this, we have completed projections of planes. If you have any doubt in the earlier two topics, not only two topics, in any topic of engineering graphics, so feel free to call me, or you can call Lakshman Rao sir as well. I'm telling you my contact number here. My number is 7842409596. I repeat, 7842409596. If you have any doubt, feel free to call me. So let us end up this session. And all the very best for your examination.